velocity time graphs. Come on, pull it together, man. Close the door. Now, before I start, I should tell you that in high school we always called it time velocity graphs. So if I say time velocity, I should try and say velocity time, because that's how it's written in most books now. Okay, velocity time graphs. So what are they? Well, they're a graph that has on the x-axis time and on the y-axis velocity. And that would be meters per second, of course, and that would be seconds. So, let me give you an example, simple example. A man starts at rest and then he starts to walk. So, just that. Starts at 0 and then maybe reaches, let's say, 2 meters per second. The formulas I gave you last time will let you find things like acceleration, distance traveled, stuff like this. But those formulas I gave you last time only work if the acceleration is constant. So just as a side note here, those SUVAT formulas, that is only if A is constant. So, an example where it's not constant, who can give me an example of when A is not constant? But it's still constant, it's just 0.
Just a general person is running. But you can't really run for a long time with the same acceleration.
Yeah, well, that's a fair enough example. If a person starts at rest and then they run, they accelerate. But they can't keep running faster and faster. Sometimes, eventually they have to stop. So they start with positive acceleration and then they finish with negative acceleration. Okay? So that's one example. The best way to deal with those problems is by using this graph here. Yeah?
What's the time in here? Like, how can we build a graph at that time?
Yeah, well, the graph's not finished yet. So what I'm going to show you is an example. For example, a person starts at rest and then they walk and they stay walking. They walk at 2 meters per second for some time, and then maybe they get to some traffic lights and then they have to stop at the traffic lights. So this is what their graph would look like. They get faster, constant speed, and then they slow down. So maybe this here, this could only be maybe 1 second. Maybe this could be, so if I do it here, that's 1, that's 11, and maybe that's 12.
If the traffic lights, then the last line should be perpendicular to the x-axis.
Perpendicular?
They reach the traffic lights and they stop immediately.
Well,
it takes no time for them to stop.
But it always takes some time. If you prefer, you can draw it steeper. But we're assuming they casually come to rest. So, that would be an example of somebody who starts at rest. So they're at rest. And then they start to walk. And then they're walking at a constant speed, and then they slow down. Slow down. And then they stop. Okay, so when we look at this time velocity graph, on the x-axis is time, and on the y-axis is velocity, but there's lots more information into the graph, on the graph, which I'm going to do now. Okay, so if I just go down here.
The area of the graph is the acceleration or distance.
Ah, yeah. Which? Commit to one. What are you going to say? We're going to work it out now. So, yes. Now, UVATS. Which letter represents the speed at the start here?
U.
So that's U. And then the speed at the end here? V. And then what would this one here be? T. Now, let's work out the slope of this line. This is the point 0, U, and this is the point T, V. So the slope would be V minus U over T. Now, what's that? Change in velocity. Yeah, very good. Change in velocity over time is acceleration. So this is our first result. The slope equals the acceleration. First result. Okay, and then second result, what I'm going to do, if you can see that, is I want to calculate this area. So I'll break it up into a rectangle and a triangle. So how high is this piece here? U. And how high is this piece? V minus U. Okay. So the area equals T multiply U, that's the rectangle. Can you see that?
Mm-hmm.
Plus a half the base, which is T, and the height, which is V minus U. Now, that's UT plus a half. Now, if you want to think about it like this, you could even use this formula. If I take the T up to the right here, you have this result. V minus U equals AT. So that's a half T multiply AT. So that's UT plus a half AT squared. But what's UT plus a half AT squared? It's S. So that gives us our second result, that the area on the graph equals the distance.
Under the graph?
Yeah. If you want to be more formal in your language, you should really say the area under the graph. Yeah.
So why do we use trapezium? The area of a trapezium is fine this time.
Oh, well, that's basically the same thing I did there. It's just we don't cover that formula in maths or physics, so I just broke this up into a rectangle and a triangle.
We have it in the formula book, the trapezium area.
Do you? I don't think you
I
do.
think we will have it.
I'll check it, but I don't think...
Anyways, you can split the
Don't
trapezium
do-
into triangles and a rectangle.
Yeah, I don't think it's in our formula book. Okay, so area is distance and slope is acceleration. So I'm going to go back to the example at the start. Do you have this taken down?
Yeah.
Yeah. So back here. So the slope. Okay. How big is this height here? 2. And here? 1. So the slope is 2. And here, how big is... Oh, sorry, I'll use a different colour. The slope is 2. And here, how big is this? 2. And this is 1. So the slope is 2 over 1. But it's going down. So negative 2. Now, let's get the area. Okay. The first piece is a half multiply 1 multiply 2 plus, now what's this piece?
2 times 10.
Yeah, 2 multiply 10, and then the last piece is a half, and how big is this base? 1 by 2. So that is 22 in total, isn't it?
Yes.
So that's the distance this man has travelled, is 22 meters. That's his distance, is S. And that's his acceleration, and that's his deceleration. I'm going to give you a graph now, and I would like you to give me the distance travelled by the person. Can I draw the graph?
Yeah.
Okay, so we'll do a car or something. So starts here, goes up, goes across, and then goes down. And this here can be 60 seconds, and then this here can be after 10 seconds, and then this here can 50 seconds or whatever. Velocity, seconds, meters per second. And we shall make this this here 10 meters per second, and we'll make this here 20. No, we'll make this one here 30, and this one here 20. And what I mean by that is the one here is 20.
So we need to find area and
Yes, give me the area. Well, give me the distance, and then give me the acceleration. Well, I think that's easier to do first. Give me the acceleration, the deceleration, and the distance travelled. So I want A, and then I want A again. This is at the start. This one I want the acceleration at the end, and I would also like the distance travelled. Velocity time graph. Okay, I'll give you a minute to try this. I want those 3 pieces of information. Yeah. Yep, and the acceleration at the end with deceleration. You think you have it? All 3?
Yeah.
Yep, okay. So the first one, the acceleration is the slope, and the slope here, you can, now look, if you want, you can use your formula in maths class too. So if you wanted to, you can say the first point is 0, 10, and then the second point up here, what's that? 10, 30. So then the acceleration would be 20 over 10, which is 2. But if you want, you can just do it by looking at the triangle. It's this number divided by this number is this slope also. It's the same thing. 20 divided by 10. Now for this piece, it would be 10 divided by 10, yeah? But it's going down, so it's minus then.
If we use the math formula, then
It will come out as a minus, yeah. Minus 1 meter per second squared. 1 meter per second squared. Okay, so the area, I will break it up into, let's see, I could do 2 triangles and 2.
Yeah, we already
Yeah.
have 2 triangles and there is one.
Yeah, I'll do it. Okay, I'll do it like that. So that triangle, that rectangle, that rectangle, that rectangle. Okay, so this one I can see is just 10 by 10, so that's 10. This one here is 10 by 20, so that's 200. This one here is 40 by... Oh, sorry, is that not right?
That's 100. 10 by 10.
Oh, yeah, and I wrote 10. That's stupid. Sorry, 100. 10 by 20, 200. 40 by 30 is 1200, 1200, yeah? Now, half the base, which is 5, by the height, which is 20. So is this 100 also? Yeah. And then half the base, which is 5, by the height, which is 10, so that's 50. So the distance travelled would be 13, 14, 15, 1650? 1650 meters. I've seen this question in the exam. Pretty much the exact question. So when do you use time velocity sorry, I did it. When do you use velocity time graphs? Yeah, but in what situation? Yeah, when the acceleration is not constant. If the acceleration is constant, we can use our UVATS formulas. Okay? Right, I'm going to go on to the next section now, which continues on from the formulas we did yesterday. Yeah?
Area is the distance on the graph, right?
Yeah, the area on the graph is the distance travelled by the object.
So the area is the distance traveled by the object.
Yes.
You have to include the 200 in the 1650.
Did I not add in the 200?
Yeah, you added, but
Yeah.
why can't we go without adding it? Because isn't it the line didn't touch the ending point?
It's everything that is underneath the graph line. So that would be everything here. Oh, because I didn't put the line going down here?
Yeah.
No. It's everything under. Yeah. Okay, can I scroll down? Yes? Yeah.
How did you get A to this one?
The last piece here. This point here is 50, 30 here. And this point here is 60, 20. So you can use the formula from maths class to get the slope. So what would that come in as? 20 minus 30 over 60 minus 50, which is minus 1.
Can't we use the equation to find the area under the graph?
Not here actually, because you do not have one smooth function that describes this shape.
Oh, alright.
Okay, can I scroll down now? Yeah. So next now. Yeah, page 40.
What is projectors?
Projectiles. Yes, let's see. Does anybody know this word, projectiles? What is it?
It's like when it goes into a cloud.
Yeah, something moving in the air that's thrown. Do you remember last time I did the example of the ball that's thrown straight up in the air?
Yeah.
What speed did we say it was thrown up? 20, was it? Okay. Now, let's add to this problem. Let's say the ball is also going horizontal with speed 10. Now, let's make it actually a bit easier. Sorry. 15. So last time, what did the ball do? It just went up and down. But now, because it has a horizontal and a vertical speed, it will travel like this. So this has now an X and it has a Y. And this is the important thing. X and Y are independent.
So we can't resolve.
Now you can resolve it and you can unresolve it, but what I mean by saying X and Y are independent is that the 15 does not affect the 20 and the 20 does not affect the 15. So in other words, if I make this number here bigger, it has no effect on this number. In other words, they can be any two numbers. You know, it could be what? 206 million. Like, there's no relationship between the two. They're free to be any numbers.
Is there any example that they're the same, like they're dependent on each other?
No.
The only way you could make them dependent on each other is if you had some kind of machine that was, you know, affecting it. But just naturally, it is actually impossible that they must be independent, that you could never make them dependent unless you use some kind of machine to interfere. No, there's no natural example of one where they're not independent. So they are independent. So independent here means they don't affect each other. They can be any numbers. Okay? That's a good thing. It makes the calculation easier. Okay? The way to deal with this, so what I would like to do is I'd like to know the time it takes, oh yeah, and we'll make it 100 again. The time it takes to hit the water, like last time. Now tell me, what was the time we got last time?
7 seconds.
7 seconds. So do you think it will still be 7, more than 7, or less than 7?
Less.
More than
More than.
Less? More?
More
Yeah? What do you think, Donna and Soon? Do you think the time here will be more than 7, less than 7, or 7?
Less.
Don't be shy. I only want to see what people think. So what do you think? You think less, okay? And you think more, okay. Anyone else? No. So you're all wrong. It'll be the same as 7. Now why is it this? Why do I know it's the same as 7? Because remember I said the X and the Y are independent. So last time, wait. Last time, what was the Y? What was the speed of the Y? 20. And what's the Y here? 20. It's the same, going to be the same answer. That this X here does not change.
Oh yeah, because they don't affect each other.
They don't affect each other.
Yeah, it means that. Okay. So it will go the same distance at the same time. Yeah.
Yes.
That's.
So what do you mean by modify each other, like independently?
If speed of one will change, the speed of another will not.
In other words, yeah. Last time we had 20 vertical, and what was the horizontal? 0. This time we have 20 vertical and 15 horizontal. But the time it takes to go up and down doesn't change.
Oh,
Yeah, so I'm going to actually calculate this now. Okay, I'm going to do it like you would in the exam. So what you do here is you break the problem into two. Okay, this is the x, and then this is the y. So you really have to kind of use your imagination here. But when the ball is here, it's like there's an x here, and then there's... Hang on. What do I want to do? Yeah, here. This is on the x-axis. Sorry, I know that looks terrible, but that's on the x-axis. Can you see that? Like, this is the x-axis. And then on the other one is the y-axis. So what happens on the y-axis? It goes up, and then what happens? It stops and goes down to here. So when the ball is here, this is what it is on the x, and then this is what it is on the y. When I was in high school, the way I always picture this is like the ball is here, and there's a little laser, you know, laser? And the laser is pointing on the ground, and it makes a dot. And then the laser is pointing on the wall, and it makes a dot. So when the ball starts to move, what happens to this dot on the wall? It goes up, it goes down. And then what happens on the dot on the ground? It goes across. But when you look at this dot on the wall, what's its speed going up? Yeah, same speed, 20. And that's the same problem we did last time. And this is the point I'm making, that you can consider this as two problems in one. Okay? So the y, we did this last time, didn't we? What's the u? No, 20. The v, we don't know. The a, minus 10, or minus 9.8, 1. The t, we don't know, but we worked it out as, we got it as 7, didn't we? And the s, we do know the s. Sorry, it's not clear. Here it is on the picture. So what's the s? Minus 100. Now, when I did the calculation, you said you got t equals 7, or 6.99. Okay. So that's how long it takes. But now, I would like to know how far the ball has moved out into the ocean. I want to know this distance here. And this is called the range. So, if I look at the horizontal now, I have U, V, A, T, S. Shh. Hey, get your head up. What's U? Horizontal. Oh, what the heck have I done? Sorry, I wrote them backwards.
Yeah.
Y, X. Okay. U, 15. V, not given. A, no.
no.
Y, 0.
Constant velocity.
Yeah, but why is the A 0 horizontally?
Because there is nothing.
Yeah?
It doesn't speed itself up.
Yes, and what are you saying? Yeah. This falls vertically. It doesn't fall horizontally. So in the X, there is no acceleration this way. There's only acceleration this way. Okay? So the A is 0. Now, the T, what's the T?
7.
Yes, it's 7. And the S is what we want to work out. I know the T is 7 from here.
Oh, the V then is 0.
Oh, well, not 0, but 15 then, if it's not accelerating.
Well,
We're looking at the moment just prior
Okay.
to hitting.
So V is
15. Now, that's important. The time that, now just, it makes sense. The time that passes horizontally and vertically are the same. So, when this moves up 1 second and this moves across 1 second, here t equals 1 and here t equals 1. Okay? So if it takes 10 seconds to go like this, then it's 10 seconds this way too. Okay? So I did say they are independent, and that's true. The speed here does not affect the speed here. But time is different. Time is true for everybody. So 5 seconds, t equals 5 for me is the same as t equals 5 for you. If I wait 5 seconds in this room with you, you are also waiting 5 seconds. Okay? So the t is the same always for both. But everything else is different. The u different, v different, a different, t the same, s could be different also. Okay? So I want you to tell me the s, please. What's the s? I want you to calculate it.
It's almost the same.
100.
For the horizontal and the
It's
vertical,
just- It's
yes.
just U times T.
Yeah, in this case it is. Yeah.
105.
105. Yeah. 70 and 35. 105 meters. Yeah. So how far has the ball travelled? We don't really know because remember distance would be the curve part. But we know what the displacement is. So horizontally, what's its displacement? 105. And vertically?
Minus 100.
Minus 100. Okay. Now, I'm going to give you one to try. No, actually, I'll do another one and then I'll give you one to try. Yeah, that's the next one I'm going to do. What's the S, did we say? 105. Okay. So I'll do one now that, as you said, has an angle in it. Okay, can I go down? Yep.
Yeah.
All right. So, in this case, here, let's say, is 20 meters per second at an angle of 30 degrees. So the ball goes up and then down like that and crash. Okay. So you'll notice that the problem here is you do not know the horizontal and the vertical. But what do we do? Resolve. So how big is this one here? 20 cos 30. And then this one? 20 sine 30. So if I split vertical, horizontal, U, V, A, T, S, U, V, A, T, S. Okay. So can you type those in on the calculator? Tell me what you get, please. Well, I know the A here. And I know the A here. Yeah? Oh, I'm using 9.8. It's my own question. Oh, U is 10, yep. Okay. The vertical is 10, and then what's the horizontal? 17.3. V we don't know, T we don't know, S we don't know. But we could know S. It depends what I'm going to ask. Okay, so my question is I want the... let me write it in red. Time of flight. Oops. I want the time of flight. Time of flight means the total time for the journey. How long it takes to start here. Oops. And then end here. Okay. Who can tell me what the S is vertically? How far has it displaced vertically? What's the S for the vertical?
0.
0. Because if you think about it, the ball has gone up and back down, so the vertical displacement is 0. Goes up and down, so it's 0. Okay? So,
and why do the acceleration 9.81? I mean negative 9.81?
because it's going down.
Isn't that going down is positive?
No, we talked about this last time. I said, if I call up positive, then acceleration down is negative. And I'm calling up positive and right positive here. Oh, you're looking at me like I never said this before. Look, if I say up is positive, then gravity is negative. If I say down is positive, then gravity is positive.
Yeah.
And then up will be negative then.
In this case, 20 is positive.
Yes.
So,
Well, 20 cos is positive and 20 sine is positive. So that means the gravity must be negative to be opposite. Okay. Now,
What about why V is 0? Right? Because it stops.
no. Again, you just asked me that. It's immediately prior to the impact. Yes. I've lost my train. Okay. I want you to get me the T first. Alright? So that's your exercise. Get me the T here. Yeah, well, I'll just give a chance for everybody to do it. So, exactly or approximately? Yes, 2.04 then we'll go with. Yes, you give me 2 decimal places. Oh, actually, no, that's 1 decimal place there. Okay, 1 decimal place. Is it going to be 2 then?
Yeah, X to the Y.
For the Y.
V is 0.
Why is V0 in this case?
Oh,
Because you're going to say the same thing he is. When I'm looking at these problems, okay, and I look at the V, it's always the velocity just before it hits, not after it hits. Always, without exception. Alright, have we got the T? Is that a yes? We have the T. Yeah, what do we get for the T? 2. Do we get 2?
I didn't get it. Which formula did you use?
What formula did you use to get the 2? Which one?
Basically, it was UC.
Alright. Oh, that one. Yeah, but if it, which
one?
yeah, S equals ut plus a half at squared.
I got 0 and negative 2. I used that formula and I got 0 and negative 2.
You type something in wrong.
No, because it's t squared, so we have to find the t.
Yeah.
Oh, yes.
Yeah.
Wait, hang on. Did we get 2 or do I need to do it?
I got 2, but it's negative 2.
Then you've done something wrong then. It should come out as positive for sure.
Yeah.
Got 2?
Yeah, just basically for
V squared equals yeah, I mean, alright, I'll do it. So if you look here, I think probably the easiest way to do it actually, if you wanted to avoid messy equations, I'll go with V squared first. V squared equals U squared plus 2AS. V squared equals 100 minus, so can somebody type in 2 multiply 9.81 oh wait,
1960.
no, S is 0, so it's just 0. So V is minus 10 because it's going down at the end. You take the minus answer. which I think Dana was telling us last time, if you remember. So now we can go with the t. I can just say v equals u plus at. So v equals u, and then the a, and then the t. So then the t will be 2 here. So that means the t here is 2. Yep. Now, did somebody just say why is the T2?
No.
Do I need to? I left out some steps in between here. Do I need to write them down?
Yes.
Okay.
Wait,
Minus 20 minus 9.81 T. So T is minus 20 over minus 9.81, which is 2. Yes, to 1 decimal place. Yeah.
That isn't. Are we solving T for Y?
Yeah.
Then why is the? Because it's the same time. Oh.
Yeah. Now, what I want you to do next for me is to get this one here, this distance here, which is called the range. So that will be this S here, wouldn't it? Yeah. Oh, what did I say? T is 2. All right. Give me the S here.
24.20.
Yep. Using which formula? UT plus a half AT squared. So it's 34.6 meters.
It's just U times T.
Yeah. The A is 0. And finally, I want you to tell me
The vertical.
this here. Now, that's a separate problem which I need to remove. Can I remove this here? Yeah, just this information. S is not 0 anymore. T is not 2 anymore. And S here is not 34.6. If you think back to the last class, what did I say is special about the top here? What's special here? The velocity is 0. Which velocity? The horizontal or the vertical? The vertical. So here, V is 0 this time. So please calculate for me the T. I want the T.
But we don't have.
You can get me the T. You have enough information. You have UVA.
It's 1.1 second.
Yeah, so it's basically roughly 1 second, isn't it?
Yes.
Now, if I want the height, do I want the horizontal S or the vertical S? Vertical. So your next thing to do for me is to calculate the S here, which gives you the height.
Five.
5. What formula did you use?
S equals a half A plus V. Yeah.
You used the U plus V over 2 one, was it? Yeah, that's probably the quickest. A half, or U plus V over 2 times T.
Yes.
Oh yeah, so 10 plus 0 over 2, 5, yeah. Cool. Alright, so that's then projectile. So let me give you one more to do yourself, and then we'll go on to the next topic. So can I scroll down?
Yeah.
Yep. Alright. So we're back now at our cliff face. as it goes up and then goes down and lands here. What would I like? I would like, yeah. I want to know how far out from the cliff it lands. So I'd like the range. That's what I want. Okay, I'll give you a minute to calculate that. That's a 50 up the top here. 50.
So the speed.
That's a speed that needs to be resolved. Hmm? 9.81.
Okay. What range is the speed?
Huh?
Is range speed?
Range is the distance horizontally. The x distance.
Oh, this angle there, same speed.
Should do because of the 45, yeah. Okay, so some people have an answer? Almost? Where's your answer? 5.1. I don't know, that seems a little on the small side because it's gone 50 meters per second, so after 1 second it would have travelled at least, I would have thought, 20 meters horizontally. Yeah. I think so because the speed is 50 meters per second. time?
Yeah, that's right. And no, there's no time. It's the range.
Oh, that would be a problem. I think it was time. Oh, what else has an answer? Not yet.
What is the answer? Or you don't
I
know?
don't know, just made these numbers up. So I don't know. I'll tell you now though. Alright, let's have a look. So, this one here is 50 cos 45. What's that?
35.4.
35.4.
Vertical is the same.
And vertical will be 50 cos, sorry, sine 45,
Which is then 5.4.
which is the same. Yeah.
Is it? Or you do the answer?
I don't know the answer now, so I'm going to get it now. Right. Hey, come on, look. So vertically, UVATS. U, 35.4. V, we don't know. A, minus 9.81. T, we don't know. S, minus 100. I'm going to get the V first. So V squared equals U squared plus 2AS. What's that, please? 200 multiplying 9.81.
196.
How?
196.
Hey.
3 to 1 count.
Calculator, please.
Wait.
196.
This is the answer.
No, but I didn't want the answer.
196.
Okay, now.
I can trust you. So the next number is 1961. 1962, yeah? Oh, for goodness sake, what is it? 1962. Alright, so in total, what is this? 3215.16. Right. Okay. So if I want the V, I need to do a square root now.
56.7.
That's now I want it. 56.7. Okay. Meters per second, yes. Right. Now I can get the T by using this formula. V equals U plus A T.
But you get negative, so.
No, you won't get negative, Tanish. You'll get positive. I promise you. Oh, wait, hang on. No. Sorry, Tanish. So it's not 56.7. Dana? It's minus, isn't it? Now you should get positive. Yes, the 56.7 is negative, and the T will be positive.
So why is 56.7 is negative?
Dana! Tell him why.
Yeah, it's negative.
Alright, okay.
Just because it's negative, that's all we need to know.
What? Now what's the T?
9.4.
9.4.
Yeah.
Yeah, okay. Now, I want to find the range. So, X, what's U? 35.4. What's V? Don't know. What's A? What's A? 0. What's T? 9.4. So now give me the S.
352.
S equals U, yeah, T plus a half A T squared. So what did you say it was?
352.3.
332.3.
Yes.
Okay, so 333. No, we'll do it. 332. I don't think anybody got that answer.
Yeah, I got it.
Your answer was very big, your answer was very small.
332.
And I have, oh, that's the horizontal range, yeah?
Is that what we're looking
Oh, yes.
So it's S.
S, yes.
So the negative positive means that.
What, Tanish?
No, the negative positive does not ruin my life. Like it made me stop thinking. I got stuck all then.
You need to be careful with the
Yeah.
positive and negative. Now, I have seen this question in no, as a part of a longer question, okay, in section B, but I've only seen it once, so it's not that common. Okay, a little bit of definitions now. Can I scroll down? Yep.
What about the other moments? Like, see, we said it too.
No. We won't do it that way. We'll always do it as a process rather than a formula. But you talking about the formulas that have like cos and sine t in it, time of flight equals, yeah. I mean, if you want to use it, that's fine, but the problem with those formulas is it only works if it's on horizontal ground. It doesn't work in this cliff case. And it's not in the formula book. So I think it's much better if I do it as a process rather than as a formula. But I mean, if you want, you can use it. I have no problem with it. But you'll need to remember it. Okay. Now, let's give an example. I've got here one car, and let's say this is only a definition I want to give you. This here is 20 meters per second, and then this car here is going 30. No, that's stupid. Don't do that. 10 meters per second.
Okay.
Car A will catch up to car B eventually, and we'd like to know how long this will take. There's two ways to do it. First way is to think about it like this. Oh, and I should tell you the distance at the start, that they're separated by 100 meters. Okay, so they start off like this, but later they'll be together, and then what will happen in the next moment? Which car will go ahead? A will go ahead. Okay, so what do we call this in English? Overtaken. Overtake. Yeah. Now, there's two ways to do it. Let me show you the first way. Oh, and there's no acceleration here to make it easy, okay? The first way to think about it is, let me call this here the total distance. I don't know what it is, but I call it S. Now, this distance here, is that the distance that A has travelled or B has travelled?
B.
No, not B, just A, because B does not start at the beginning here. Okay? So, at the end, the distance A travelled, so that's this blue line here, that should equal,
X.
well, hold on. See this here? That's the distance B has travelled, isn't it? Well, we don't know, but we know that whatever A has travelled, that should be the same as B plus 100. So the distance A has travelled should equal the distance B has travelled plus 100.
Okay.
At the end here. You can see it, like there's 100 plus that distance should equal that distance. Yeah? Now what's the formula for S? ut plus a half at squared. But if the a is 0, then it's just ut. So SA would be 20t. And what would SB be? That would be 10t plus 100. So you can work out t. What does t work out here as? 10. So how long until this? 10 seconds. If I want the distance, I can just put it into my formula. So let's say SA would equal 20 times 10. What's that? 200. And then SB would equal 10 times 10, which is 100. So you see what happens is A travels 200, then B travels 100, but it's really in total 200 as well from this line. So they're at the same place. Okay. That's one way to do it, but that's maybe not the best way to do it. I mean, it's fine. But another way to do it is to think about it. Well, actually, wait a minute. You need to write that down. I'll show you the other way.
Is that find the distance?
Find the distance from the traffic line, traffic post, or whatever. But I think normally the question would just be find the time. How long until A overtakes B? It's 10 seconds. Okay?
Isn't it sort of intuitive? Isn't it sort of intuitive?
No, it is. Yeah, you're right. And in fact, the way I'm going to show you next is kind of the more intuitive way. Yeah. Okay. Can I scroll down yet?
Just
Yeah. Okay. Scrolling down. Oh my goodness, Mo, hurry up. Yes, you got it. Okay, so the second way to think about it is, here's the first car. How fast is this going? I think I said 20, didn't I?
Yeah.
Here's the second car, and I said this here is 10, and the distance here is 100 meters at the beginning. But if you think about it like this, when this travels 20, in 1 second this travels 20 and this travels 10, what has happened to the distance between them? Has it gotten bigger or smaller? Smaller by 10. It reduces. So this gives us the idea of what's called relative velocity. So if you picture it like this, the person in this car will see this car traveling at 10. Okay? So, you know, if you think about it like this, the difference, yeah. So if this car is moving at 100 meters per second, and the car behind it is moving at 100 meters per second, then it looks like it's 0. They stay the same. But if the first car is going 100 and the other car is 0, what does it look like the other car is doing in the window? 100. Forwards or backwards?
Forwards.
No, backwards. If you think about it, if you're sitting in the car and the car behind you is not moving, what does it look like is happening? It looks like it's going further away, backwards. Yeah. Now, if this car is going 100 and the car behind it's going 110, it looks like it's moving slowly at you with 10. Can you picture that? Yes? No? Yes? Yes? So, if this car is going 50 and the car behind is going 40, what does it look like to the person in the front? What? Yeah, which way? Forwards or backwards?
Forward.
Backwards, because it's 50 and 40. So this car's going faster.
It's going backward by 10.
Yeah, it looks like it's going backwards by 10. But then the person in the other car, what does it look like the first car's doing? It's going forward with 10.
So like we can say that like it's going to they're going to each other like in 10 seconds because like can be he says that car it drives like 10 seconds
10 meters.
10
Yes.
meters per second.
Yes.
And the difference between them 100 meters, so it's going to meet each other like in 10 seconds.
Yes, that's the idea. Yes. It takes the relative speed is 10, and how far apart are they? 100. So if it's 10 meters per second and it's 100 meters, then the time it takes 10. So I think this is what you were saying, Mohammed, as kind of the intuitive answer. And you're right. You can just think about it like this, and you also get time is 10. It's 100 divided by 10. Okay. So what I really want you to learn from this is the idea and the vocabulary called relative velocity. Okay, so please make note of this.
Can you give an explanation of relative velocity?
Yeah, it's relative velocity would be the velocity as it appears to an observer.
So how did you get the time from that?
Well, as I think Mohammed was saying here, the speed is 10 meters per second, and how far apart are the cars? 100. So if you lose 10 meters every second, how long until it becomes 0? Well, 10 seconds. It goes 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. 10 seconds. Yeah. Okay. It's a difficult decision now for me to do more or to do more questions. Let me think carefully about this.
More.
I don't need to think about that, yes.
More.
Craig! No way, man.
More.
Shh. Teacher
Give us
thinking.
an example for that.
Teacher thinking time. Decision has been made. I will do some more.
Yay.
New topics, that is. So, I'm going on to the next topic now. Yeah, no, there's plenty of time. Okay. Can I scroll down?
Yeah.
Okay. Big man himself, Newton's laws now. Okay. Well, we all know Newton. He has 3 laws. So what are his laws? His laws of motion. So his first law, number 1. Well, does anyone know his first law? Yeah?
Every object in motion, so every object tends to stay in constant motion unless acted upon by it.
That's it. So we say a body, let me try and simplify this. A body at, there's so many ways you can phrase it. I'll just say a body at rest or in constant velocity or constant motion. Constant velocity, we'll say. Will remain at rest or constant velocity, if that's what it's doing.
Unless.
Yes. And here's the kicker. Unless acted upon. No, I see that English is not nice for you. Unless a force acts on it. So, in other words, if something is at rest, it will stay at rest unless a force moves it. I mean, that makes sense.
Yeah. Is the second one about the reaction?
Ah, that's the third
that's
one. Yes, yeah. Okay. So the second one now. Now again, there's many different ways to say this one. What did I go for? Well, that's as a formula, yes. There's a few different ways to say it. You could just give it directly as a formula. Force, but I won't. Force equals the rate of change. Oh, I kind of am. Of momentum. Now that needs a definition which I'll do on the side. I'm going to expand this on the side. So now we have to say, well, what the heck is momentum? So can I go to the side now? I'll go back to this, don't worry. So to the side here. So this is a definition. Oh my goodness, is it momentum? What did I put two M's for? Momentum. Momentum, if you want, it's just a simple formula. It's mass multiply velocity. So for example, if this is 10 kilograms going at 20 meters per second, its momentum, or what letter do we use for momentum? Does anyone know the letter? It's a little p, isn't it? So we say what's the momentum here? It would be 200. It's just mass multiplied velocity. And what's the unit? Yeah, well, it'll be kilograms meters per second. Now let me take this example. This is 20 kilograms going at 10 meters per second. What's the momentum here? 200 also. So please notice how these are different masses with different velocities, but we have the same momentum. So what exactly is momentum used for? What does momentum tell us? Well, momentum tells us how difficult it is to stop. So the bigger the momentum, the more difficult it is to stop it. Okay? So if I want to stop this person or car or whatever it is, and if I want to stop this person or car or whatever, it's the same difficulty. Okay? So momentum is something that tells us how difficult it is to stop. Okay? So if you think about it, a little bullet, its mass is small, yes? But its velocity is huge. So its momentum, huge. So a bullet is difficult to stop. But if I say this here, mass, small, velocity, small, so it's easy to stop. So momentum really is an indication of how difficult it is to stop something. Are we happy with the idea of momentum? Yeah. So now I have to go back to my formula, my definition. So, it's the, look here at the key words, change in momentum. So what's the momentum at the end? What letter is for a V? And what's the momentum at the start? mu over t. And the t is because of this word, rate, would mean the t here. Right, now, but you can say, well, I will just take the m out, and then I have v minus u over t. But what's that? That's acceleration, isn't it? Which is ma. So now we have Newton's famous second formula, F equals ma. Yes?
Is it the reaction force is always equal to the action force?
Yeah. There's so many ways to say it. In the book here, they talk about opposite force. For every action, we'll go with this one. Yeah, there. No, sorry. There is an equal but opposite. No, I won't even say. Oh, yeah, well, it's.
Just reaction.
Oh, yeah. Let's simplify. For every action, there is a. Yeah, you can write that in. I'm just going to go with for every action, there is a reaction. We'll keep it simple. So in other words, if I do stuff, stuff should happen. Yeah. Keep it simple. Alright. So like here, I'm pushing this table and it looks like nothing is happening. But what actually is happening?
The table is pushing.
No, let's not go complicated. The table is pushing back. Yeah. So if I push the wall, it looks like nothing is happening, but there is something happening. The wall is now pushing back, which it wasn't doing before. Is this wall pushing me? No. There'd be a problem if it was pushing me now, because that means it's falling on me. Right? But now, it's pushing. Something has happened. Now it's not pushing. So, in other words, I do stuff, stuff should happen. Okay. So there's Newton's three laws. Of the three, which is the most important? 2, because it has the formula in it.
All of them are equal there.
Oh, well, they're all important historically, blah, blah, blah. But for physics class, number 2 is the one you use the most. So let's have a look at some examples.
Actually, no, we haven't used the second one before.
We haven't used it yet.
Yeah, but for all of the tasks, we use the third one.
Yeah. For what we've been doing so far, yeah. Let's have a look at an example. Do you have those 3 laws? Yeah, okay. Right. Let's have a look at the rocket example here. Okay. So, for example, you have your rocket here. A rocket develops an initial thrust of 3.3 times 10 to the 7 and has a liftoff mass of that. Okay, so this rocket here, its mass is 2.8 times 10 to the 6. And then take off. Yes.
Is it hard?
Yeah. Yes.
Too many responses.
Too much. That's internet addiction. It's terrible. All right. So going on here, the force from the engine going up, we're told, is 3.3 times 10 to the 7 newtons.
What did you write with it?
Nothing.
Nothing at all. Okay. there you go. You have your mass, you have your force, so we would like to work out the acceleration. So let's work out the acceleration. Well, you tell me the acceleration. You work it out for me. What's the acceleration? Yeah, work it out, please. Use your formula, F equals ma. Yeah.
11.7.
That looks really big as an acceleration.
11.8.
I think you need brackets if you type them in on your calculator. What is it?
11.8 meters per second.
Yeah, did you all get that?
Yes.
Oh, you're wrong. You're wrong, right? Sorry, I was being a bit of a troll. I tricked you here a little bit.
Oh, because the acceleration goes in.
What did you forget?
The reaction force.
Not the reaction force.
The gravity.
Yeah, that is not the only force. There's another force. What is it? The weight. Pulling the rocket down.
Yeah,
So there's a weight down here. So, don't forget, there's a weight here of 2.8 times 10 to the 6 g. So, when you use your F equals ma, that F there is the total force. So what do you do with this number? Do you add or subtract it to that? You subtract. Now calculate it. Yeah, you see that 2.8 times 10 to the 6 g? You take that away from the up force to get the total force. Because that force that's going down is hindering. It's almost like a friction. 9.81.
1.9.
There we go. That's more like it.
2.
Do they have inputs? Yeah, it comes up later. Okay. So what did we get? Sorry, can we say that again? The answer is
1 point what?
that sounds a bit too. Oh well, sorry. In the book they say to use g as 10. So
Okay.
no. Well, if you use 9.81, you get 1.97
1.7 for 10.
for 10. Yeah, okay. But for 9.81, 1.97. Okay, so 1.98 if you round it off. 1.98 to 2 decimal places, yeah, or 3 significant figures. So here, the A would equal the F over M. So the A equals, what was the up one? 3.3. 3.3 times 10 to the 7 minus 2.8 times 10 to the 6 times 9.81 all over 2.8 times 10 to the 6. So that's the acceleration. Okay, next question for you to do. You listening? I won't write it down, you need to listen. The rocket starts at rest. Okay? Now you don't have to write that exact sentence down, just understand what I'm saying, okay? The rocket starts at rest. I want to know, after 1 minute, how far has it travelled? So it starts at rest. I would like to know how far it has travelled after 1 minute.
Is it the same?
It's the same rocket, same situation, yeah?
Mass.
Everything the same, yeah? Now, while you're working on that, borrow this. I have a little bit of questions to do.
This one doesn't work.
But this one does?
Yeah.
Okay. So what do we get? 3,600 meters.
Yeah.
So after 1 minute, the rocket has traveled nearly 4 kilometers. 3,600 meters, isn't it? Again, it depends on rounding off. I'm not too concerned about being exact right now. Okay. Anything near 3.6 kilometers would make me happy. I have one last example to do regarding force, and then I'll give you the homework. Okay. Can I scroll down? Yep. So here's the last example regarding force.
Do I have math today?
Yes.
No.
Dude, your maths teacher is also your physics teacher. Okay. I would like to know, and just to be clear, let's say there's no friction, just to make it easy in this example, and let's just say G is 10. Okay. So I would like to know the acceleration here of this, what would you call this triangle shape here? This is called a wedge. Yeah, inclined plane or a wedge, and this is called a block. Okay. So I would like to know what's the acceleration here.
Is that 10 kg?
10 kg. 10 kilograms.
That's the weight.
That's the mass. Yeah. Alright, so what we do, now I draw in my forces. So there are 2 forces. Let me just remove this to make it less cluttered. There are 2 forces here. What are the 2 forces? Weight, very good. So that is here. How big? 10 G. 100 newtons. And there's one other force. Reaction here. Which we don't know. We call it R. Okay? Now, what we need to do for this problem is we need to resolve. Do we resolve the or do we resolve the weight? That is, do we resolve the reaction force or do we resolve the weight force?
You can like make
Wait. I just want to hear resolve reaction or resolve weight. The weight force. And we do it like this. That way and that way. So it's important that you know that in this diagram, if that's 30, this angle here is also 30. So how big is this side?
that's 100.
That would be 100 cos 30. And this one here? 100 sine 30. Now, in this direction here, look, I'll call this direction y, and then this direction here, I'll call it x. In the y direction, is the block increasing or decreasing or staying the same? No, it's staying the same because remember the y is how far off the wedge. Look. No. Look. For this diagram, this is not y. This is y. The y is the distance off the wedge. Okay? Yes? So is the block staying on the wedge? It is. But is the X changing? Yes. So in the Y, there's no movement really. There's no movement in this Y. So the up force equals the down force. So that means, what does or equal?
100.
Nope, not 100. 100 cos 30. Now, in this direction, is the block accelerating? Is it getting faster? Yes.
Yeah.
So what formula can we use to find acceleration? We can use Newton's formula. What's the F? It's 100 sine 30. What's the M? No, M 10. So this is 50 equals 10a. So the acceleration is 5. Isn't it? Yeah. Now, final question, and then you can go. Let's say that the distance here is 1 meter.
Alright.
Tell me how long until the block hits the bottom, the time. Yeah, you see, it's 1 meter there, so it's going to slide down. So I want to know the time. So it starts at rest. What's the U? 0. The V, we don't know. The A? 5. The T? We don't know. The S? 1 meter.
So why is the U 0?
I'm saying it starts at rest.
Oh, it's another question.
It's in the question. I just put the block on the wedge and let go. 50 newtons. It's the force the block feels in the X direction. Give me the time to hit the table. Huh? What are you asking me? The 50? Oh, the answer. Oh, yeah. It should be less than a second, yeah?
0.4.
0. Double check. Let's see your calculation. Oh, no. There's an A this time.
0.2.
S equals ut plus 10 squared over 2. This is 0 also.
Oh, that's 0, yeah.
1 equals
That's fine.
5 times. Oh, wait a second.
Yeah. No, I think you got it there. What did
Yeah,
you say?
0.2.
0.2. 0.2.
0.2.
Oh, I need
It's so hard to see what you're doing. Let's see what you did. You got the answer? No, not quite. Something went wrong here. S is 1, that is 0, that's... Is that 5? Yeah. Oh, wait, hang on. Oh, no, this is not 2 over 5. Yeah.
Why can't I use formula?
Which formula?
You can use any formula.
You can. Yes.
But this is S is 1 meter.
Yes.
And U is 0.
Yes.
So 0 T is 0 and half A T squared is what's left.
Yeah.
So half A is 5.
A half of 5.
Yeah.
2.5. 2.5 t squared equals 1. What's wrong?
Yeah. And
So 1 equals 2.5 t squared. So 1 over 2.5 equals t squared. So t is square root 1 over 2.5. So square root 2.5, 1 over 5, 2. Square root of 0.4, which is about 0. I can only go so far.
0.6 is 0.6.
Oh, hold on. What is it?
0.6.
Is it composing with the formula?
Yeah, 0.6.
It's a, say again?
Is it composing with the formula?
Oh, you can do it some other way? Well, you can show me if you get the same answer, that's okay, but...
It was 0.2.
That's wrong. So yes, to answer your question, use the formula. Is it?
0.6. 0.
What did you get?
0.6.
Alright, fine. Alright.
So with formula we got 0.6, without formula we got 0.2.
So what have you learned?
Oh, this is formula.
Right answer. Now let me tell you which ones to do.
Wait, could you do this one now?
Oh man, Tadai's gonna go now. Right, really quick. Where's my pen? I'm about to check my battery. Yeah, it's still okay. VATS. U 0 phi don't know A 5 T don't know S1. So S equals UT plus a half AT squared. U is 0, so that's gone. S is a half AT squared. 1 equals a half 5 T squared. So 1 equals 2.5 T squared. 1 over 2.5 equals T squared. Therefore, T is square root 1 over 2.5, 0.6. 0.6. Alright. So the questions I'd like you to do for homework. Page 52. So now, on page 52, I want you to do 6, 7, 8, 9, and 10.
Enough.
No, it is enough, but please note, in number 10, you can see that there are 1, 2, 3, 4 parts in number 10.
Yeah, right.
I just need part 1, 2, and 3.
That's so generic.
Yes. Isn't it just?
Which page is that?
What?
Where's the homework? Which page?
Ask your classmates. It's page 52, 6, 7, 8, 9, 10. 52, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10.
We have 1 hour break.
And then we should just
Yeah, and then
Part 1, 2, 3.